everyone, how are you doing today? I'm 𝐂𝐤𝐤, Marketing Manager at Lambda Test, and your host for today's session. I hope you're all having fantastic time here at TestMu Conf. In past 2 days, we've got some amazing insights from some of the brilliant minds from the industry, and we have a lot in store for you today as well. Today, I'm honored to host Marit, who would be doing a deep dive into how to develop better software faster. By the end of this talk, you'll walk away with some great insights into getting the right feedback at the right time, understanding what to test, how to test, and when to test, and recognizing the elements of good automated test. Marit is an expert in this subject. She's a developer advocate at JetBrains with over 2 decades of expertise. She has contributed to various open source projects like Cucumber and much more. But before we begin, let's take care of some housekeeping items. This session will be recorded, and so just in case you have to drop in midway, no worries. Just rewatch the entire session on the TestMu events going to the schedule. We'll be having a dedicated Q&A round as well towards the end of the session. So feel free to put all your questions in the Q&A windows and Marit would be happy to answer them all. With that way out, please welcome Marit on stage. Marit.
Thank you, Sebi. So let me share my screen. And start my presentation. My name is Marit van Dijk. And thanks for pronouncing my first name, Sebi. And I'm a developer advocate at JetBrains, as Sebi just said. And I'm here today to talk to you about use testing to develop better software faster. This talk is based on an article that I wrote for 97 Things Every Java Programmer Should Know, edited by 𝐃𝐢𝐤 and Trisha G. And when I wrote the article, I had to pretty much tell everything that I wanted to say about testing into maximum of 550 words. And I thought, oh my God, I have so much more I want to tell people. So when I was invited to speak at a Java conference in the Netherlands, I thought, oh, I can do a talk on this. And that's how this talk got started. I will tell you a lot of things that you probably already know, but I'm also going to show you some examples of why I'm still saying these things. Because to be honest, sometimes I look at the tests for a project and this is how I feel. Sometimes there aren't even any tests in a project, which, is not great. And other times I know that as a developer, once I'm done delivering a feature or building a feature, at the end, if I haven't already added any tests, by the time that I'm done with the feature, I'm really, really done with the feature. And I don't want to spend any more time on it, especially if I've already spent more time than maybe I thought I would. And then having to add the tests feels really annoying, but of course necessary. So, and also if I add the tests on at the end, I tend to, and this is from my personal experience, I tend to maybe write tests that are more testing the implementation rather than the intended behavior. Of course, this is not how I want to work, but it happens sometimes. And it's really hard to kind of add on the quality at the end. You really have to build it in from the start. And also the tests are better if you at least think about them before you start writing your feature and start writing your tests. So how do you build quality in? Dan Ashby wrote a blog post that I've linked in the bottom here. I'll share my slides at the end, or a link to the slides anyway. So here, this diagram shows in the DevOps cycle for all of the activities we test here. It doesn't, of course, say what we do there. So this is where the holistic testing diagram by Janet Gregory comes in. And this describes for each of the phases in the DevOps cycle, what are the things that, or what are the testing activities that you can do. And of course, Janet Gregory and Lisa Crispin have written several books on agile testing. If you haven't read them, I'd highly recommend those. This diagram will give you an idea of the different things that you can do in the different steps in the DevOps cycle. So that means that if you're doing agile development and you want to develop quality software, you need to be performing test activities all the time, because we want to get the right feedback at the right time. We want to be confident enough that we can take the next step in our development process, whatever that next step is, whether it's committing these changes to a branch, or merging this merge request, or deploying this to production, or turning on the feature toggle. We want to make sure that we feel confident enough in our context that we can take that next step. And of course, how confident we need to be might depend on our context. I used to work at a retail platform where if we broke it, the worst thing that could happen was people weren't able to order their stuff in web shop, or it might cost us money. In neither case, anybody dies. If you're working in medical equipment or self-driving cars, you might need to be way more sure that you can take the risk of taking the next step. So if we go back to the different activities in the DevOps cycle, the first thing we need to do is start with asking questions. Marit van Dijk has said that QA means question asker. So before building a feature, ask questions to make sure that you understand what the feature should do, how it should work, and also what the problem is that you're trying to solve, because there might be a better solution than the feature that someone has come up with. Think about conditions that are described in the user story, if that's what you're using. I've had situations where we got a user story that said, if this happens, then that should happen. Or if this condition is met, then that condition should happen. Immediately, I would have questions like, if this condition is not met, does something else happen? Does nothing happen? Are there any other conditions that we need to take into account? Sometimes just drawing a flow chart so that you know, hey, there's a decision going on, so we can go either left or right. I need to understand what happens in both cases or in multiple cases. Asking questions on how it's used, what is unclear, and just getting a better understanding will mean that you get a better solution. Like I said, I don't always test first, but I do highly recommend at least thinking about certain test cases, scenarios, and examples of how this feature will be used, so that you understand what you need to take into account. I love TDD, or test-driven development, but I don't use it, like I said, don't use it as much as I should. But I do love it, and I love it especially when fixing bugs, because if I write a test first to reproduce the bugs that I'm trying to fix, or to reproduce the bug that I'm trying to fix, from writing the test, I will know that I can reproduce the problem or the bug, and that I, in fact, understand what causes the bug. And then by writing the test first, I'll have a test that if I fix the bug, I know that I've fixed that the test will pass, and I know that I've fixed the right thing. And then thirdly, because I have this test, and I check it into the code base, I know that this bug will stay dead, because we now have a test to catch it if it should reappear. And even if you don't use TDD or behavior-driven development, BDD, always think about what to test before you start implementing. Like, how are we going to see that this feature does what it's supposed to do? And don't just think about what it should do, think about what it shouldn't do as well. Always think about what could possibly go wrong, because especially as developers, we tend to think we want to make it work. And sometimes not all developers are equally good at thinking, what could possibly go wrong and what are the problems that we need to handle. Elizabeth Zagroba, who was here 2 days ago, I think, wrote a blog post called "Have I Tried Enough Weird Stuff?" Because if you're a tester or you work with really good testers, you'll know that testers are amazing at coming up with weird stuff that might break your application or show a breakage that was already there. In her blog post, she mentioned several things that you can do. One is think about falsehoods programmers believe about insert any random well-known thing, names, addresses, email addresses. Time and time zones are super fun, not, to deal with in code. And there are lots of things that can go wrong. I tried to book a train ticket in the UK recently, and it wouldn't take my last name because my last name had a space in it. Or some Irish last names have an apostrophe. And sometimes systems don't handle this. One of my favorite stories was someone who said they were building a system in Germany and the system didn't handle umlauts, which in Germany are fairly common. So that amused me a little bit. Think about your domain objects. What are falsehoods that people tend to believe about those, and make sure that you handle those. Another interesting resource is the big list of naughty strings. This is not safe for work. You can use this at work. You might not want to Google for it at work. So you might want to just save this somewhere you can find it. It has a list of different things that you can use in your testing that your system may or may not be able to handle. Another favorite thing of mine was this tweet that happened ages ago in internet time, 2014. A QA engineer walks into a bar, orders a beer, orders 0 beers, order 99999 beers, a lizard -1 beers, and a random string. All of these are fun things to see if your system can handle it. Of course, lots of testers pile on this thread and give all of their interesting inputs that you can use on your system. And at some point, InfoSec finds this thread and starts trying to SQL inject the bar and do other fun stuff. So if you are lost for inspiration on what to test, check out this thread or the resulting blog post, which has some of the highlights. And also if you just want to be amused by what people come up with. So if we know what we're going to test, we want to think about how we are going to test this. And also just thinking about that, thinking about how are we going to interact with our application so that we can test it. And at what level are we going to interact with it? This will also help you think about the testability of your application. And you might want to think about what can we automate versus what do we want to explore or try ourselves, because you can't automate what it's like to actually use your application. Most people will be familiar with the testing pyramid. So if we're talking about what level to test on, the testing pyramid says you need lots of unit tests because unit tests are very small and very fast and therefore cheap to run. You need less tests at a surface level or an integration level. And if you have a UI, I've been a backender for a long time. If you have a UI, you need even less of those, because if you want to test through a UI, you need to wait for the UI to render, for the elements to be there, for you to be able to interact with them. And all of that takes time and can make them less reliable or more flaky, because if you try to click a button that isn't clickable yet, your test is going to fail, or you need to deal with that to wait for it to be clickable, which will make it slower. And therefore, those tests will be more expensive. I rather like the test pyramid as a way of thinking about where to test or what level to test. And I personally really like to test functionality as close to where it lives in the code as I can. So if I have a class that deals with certain logic, I would like to unit test that logic so that I know if I input this into the method, I get this result. I don't need to go through the UI to know that. I might want to, at some point, have a test or a few tests that go through the UI for certain cases, but I don't need to repeat all of those cases that I have in the unit test. There is also the honeycomb model, which says for microservices, you should be focusing more on integration. And the reason, it depends. The reason that that's always the answer is because everybody's context is different, and you kind of need to take into consideration what your context is and whether that makes sense to you or not. The microservices that I've worked on were very scoped, so they had clear responsibilities of what they were doing. We could test the logic for that microservice in that microservice, and there, of course, they interacted with other microservices, but those microservices were also responsible for their logic. So we only had to minimally check that we work well together. Of course, unit tests aren't the holy grail. There are plenty of tweets that have amazing examples of all unit tests were green, but there are no integration tests. As I was originally writing this talk, Sander Hogendoorn, a developer from the Netherlands, tweeted this. And I'm like, okay, I'm immediately stealing that for my slide deck. So, make sure that you have both. Also, build testability in. You can't add it on at the top. If you have a big ball of spaghetti code and then at the end you want to think about, okay, what do we test where? It's going to be very hard to pick that apart so that you can interact with the right things that you want to test. So then I saw this tweet by Mario Fusco, who was quoting 𝐂𝐚𝐫𝐤. I hope I said that right. And if you hear someone say this code is hard to test, what they're really saying is the design of this code sucks. So if your code is really hard to test, it means that maybe the design of your code is not great, and you didn't think about how to interact with this application. Because if we think about how we're going to test this and how are we going to interact with our application to test this, that will also help the design of your code. For example, we had, in one of the microservices I worked on, we had a class that would get we had functionality that would get a lot of data from different microservices and then process that data to determine the state of an order or an order item. Now, we needed the data from, I think at some point, over 15 different services to determine that state. Originally, we'd written that logic, go get all of that information, apply some logic, and get a result. If I wanted to unit test that, I would need to mock 15 different services. So what we did instead is we pulled that apart and basically extracted the logic of determining the state based on inputs from getting that input from different other microservices or different locations, so that we could test just the logic of, if given we have all of these inputs, when we determine the status, we get whatever the expected result is. Make sure that developers are involved in creating and maintaining acceptance tests. For several reasons, the code becomes more testable. This is why TDD is important. And the developers will care more and invest more effort into maintaining and fixing those acceptance tests. This is a quote from Accelerate by Nicole Forsgren, Jess Humble, and Jean Kim, which I think is a great book. It rang so many bells for me. It was so many of what they have researched is also aligns with my 20 years of experience in working in IT. So I recommend that book as well. Next, we need to use the right tools for the job. There are lots and lots of testing frameworks. I've listed some of the ones that I've worked with or know of. I've worked mainly as a backend developer with Java and Kotlin. So most of these are Java related. If you're in a different ecosystem, you're using a different language, you might use different frameworks as well. But I've grouped them to what type of tools they are. So JUnit and TestNG are for unit testing, and you can use them to drive your integration tests as well. Mockito or WireMock are mocking tools. The HTTP client that we have in our IDEs, JetBrains IDEs. Postman and Rest Assured are ways to talk to an API. Serenity BDD and Cucumber are behavior-driven development frameworks. Spring Cloud and Pact are contract testing frameworks. Test Containers is useful if you need databases and other stuff to interact with. Excuse me. JMeter and Gatling and Locust are performance test frameworks. And of course, Cypress and Selenium are frameworks that work with your UI. Again, there might be other frameworks that you know and that you use, but each has a particular purpose, and make sure that that's what you're using it for. As Sebi mentioned, I am also an open source contributor. One of the things that I've contributed to is Cucumber, and I've been active in that community. One of the questions we would sometimes get, or we sometimes get, is, can I use Cucumber for, that means, actually, that's my next slide, use the tools as intended. One of the questions that we get in the Cucumber community, in the Slack for support, is, can I use Cucumber for performance testing? And maybe you can, but it's not written, it's not built to be a performance test tool. So it might not have the functionality that you need when you're doing performance testing, like ramping up a bunch of users or having the right measurements. It's intended to be something else. Can you do it? Probably, if you really want to, but you won't get the benefits either of Cucumber as a tool or of performance testing as a methodology. Tests should increase confidence. So again, from the Accelerate book, there's a quote that says, when the automated tests pass, teams are confident that their software is releasable. And we need the right level of confidence for our context again. And 𝐊𝐚𝐫𝐤𝐿, a tester from the Netherlands, tweeted this as I was writing this talk. As a tester, the primary concern isn't to find bugs. It's to work with your team to increase confidence in what you're building, that you're building the right thing and that you're building it right. And I really, really agree with that. So that's why I added that to my slide deck. Tests should be reliable. I hate nothing more than flaky tests, tests that intermittently fail and you don't know why. Maybe because the environment isn't up, or the service you're talking to is not available or has just made some changes, or sometimes it's race conditions, which are super fun, caching, all of these things. And a flaky test might tell you something about your system, but unless you dive into why that test is flaky and you have the time to really properly analyze that, if you have a large test suite and randomly tests fail, you might not have the time to really dive into that and figure out what's going on. And at a certain point, if certain tests flicker, they're going to be like the boy that cried wolf. Oh, that test is always flaky. We can ignore that failure until at some point there is an actual failure. So at some point I tweeted, if it's flaky and you know it, fix your test. Because I would rather not have a flaky test that cries wolf all the time than have a test that is reliable and that I know if it fails, it actually means something and I need to dive into it. Of course, when I tweeted this, Benjamin responded with, if it's flaky and you know it, kill your test. So if you have flaky tests and you don't have the time to dive into it, consider deleting them because they are dead weight and they are going to slow you down. Funny thing is, a previous version, or previous time when I did this talk, I tweeted this or someone retweeted this again. And 𝐼𝐚𝐫 actually created a song, recorded the song from my tweet. So if you want to have some fun with software and music, check that out on YouTube. Then on to some practical tips. If you have tests, please run them, because nothing breaks my heart more than people going, yada, 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 skip test. Okay, so you have tests, but you're not running them. That's like, I have a seatbelt, but I won't wear it. If you don't run the tests, they can't help you. One of the reasons that people say, okay, but I'm skipping them because they are too slow, then you have a different problem. You need to see how you can speed them up. Can you maybe push some tests down the pyramid so that they'll be faster, but still test the same functionality? If you're using retries because tests are flaky, then invest in making them more reliable. See if you can make them not flaky and reliable. And if you can't, do you really need that test that is flaky, or would you rather check that manually, or check it at a lower level, or do something to make it more reliable? Then there's the test didn't pass, so I disabled them. And I have some very interesting examples that I've run into in the wild of what people have done. So let me go to my IDE. I'm going to use 𝐴𝐵, which is JetBrains' new IDE specifically for test automation. Normally, I would use IntelliJ IDEA as a Java developer, but today I'm using 𝐴𝐵. If you want to know more about 𝐴𝐵, we have a virtual booth here at the conference that you can go to and ask more questions. So to show you some of the tests that I've seen in the wild, let me go to presentation mode so you can actually read my screen and the code here. And also, I wrote this code. Wait, let me turn off the code author so we can focus on the code. So something that I found several times, or that I sometimes find, is tests that are ignored so that they won't run as part of your build. And especially if you find this like years later, why is this test ignored? Should I unignore it? Should it still work? Should I delete this test because it hasn't run in years? I don't know. Also, ignore is a JUnit 4 annotation, so probably you want to use disabled from JUnit 5, and you want to move to using JUnit 5. If you have to disable the test, then at least add a reason why, so that whoever finds this test in the future knows why this test was ignored and they know how to handle it. Other interesting ways that I've seen tests ignored, sorry, wrong shortcut. A test was commented out. I've found this several times in the wild. If I just remove or comment out the add test, then the test won't run. You can remove the comments and see if the test still need to import stuff. We can see if the test still runs. If it does, great. If not, do you want to invest the time to fix it or not? A very creative way to not run a test is to just comment out the whole thing. I've also found this in the wild. Not great. So maybe if you go back to your project, see if you find any of these and see if you can fix them or if those tests can be deleted. The next thing is never trust a test that you haven't seen fail. I'll show you some examples of that as well. Wrong shortcut again. So if a test doesn't have any asserts, it's never going to fail. It might run some of the paths in your code, so it will add to your code coverage, but it will never fail because it doesn't actually assert anything. If you have code coverage as a metric, this might sometimes happen. And I'm not saying that code coverage is bad per se, but I do think that it's bad as a metric because it will lead to people gaming the system and just adding stuff for coverage and not for actual quality. Code coverage can help you to figure out which areas of your application are well tested or are not well tested, or at least have tests and don't have tests. So use it more as a guide than a metric. Next example, if you're using assert that by itself doesn't actually do anything. Nope, not what I wanted. So in order to actually assert something, you need to see assert something like is equal to something. Now, if we make it equal to something else, this test will fail. If we make it equal to what we're inputting, it will pass. Next example, a test that asserts true, or this is the simplest example, of course, of a test that will never fail. Not very useful. If we have a failing test, that should provide us with information. What does a failing test tell us? A failing test should tell us what's wrong quickly. How do we do that? Let's look at some examples again. So if we run this test, we will see that, of course, value and other value are not the same, so the test fails. But if we check what went wrong, I already fixed this test. So I already fixed this test preparing my demo. First, it said assert true. If we run this test, then it will say assert true, false. So the test fails. We expected true, but it was false. This is not very useful. What was expected? So if we go back, we can change this to say assert equals value other value. Now when we run the test, we will get the result. It will still fail because they are not the same. But we will see, when we press the right shortcut, we will see what was the expected value and what was the value that we got. So now we know what's wrong and we have an idea of where to go and what to fix. Next example. This, not something that I saw, but my husband, who's also a developer, came up with this example because he found that in the wild. The test name of the test says it should return true, but the assertion is assert false. So if I come across a test like this, I'm going to be confused again because what is it that you want to do here? Don't take my word for it. 𝐂𝐤𝐼𝐤, one of the editors of the book, 97 Things Every Java Programmer Should Know, he quoted me at a GoTo conference, just on the same thing. A failing test should tell you exactly what's wrong quickly without you having to spend a lot of time analyzing the failure. The next one is use meaningful descriptive names. I won't continue to go back and forth, or actually, I won't continue to go back and forth for this one, but I found tests that were literally called test scenario 1, test scenario 2. And then when that fails, you have to figure out what test scenario 1 even means. What is test scenario 1 testing? And I tweeted about finding that at the time, and Marit van Dijk, who was here 2 days ago, responded to me on Twitter saying, but are you sad 1 or sad 2? And as a developer, I say, yes. The next thing, each test should test only one thing. If you have a test that tests multiple things in a row, then if one of those fails, you don't know what the problem is, or it might hide failures. For example, I found tests that had a collection and then said, okay, if it's empty, it should be empty. If it has 1, then it should have 1. If it has multiple, then it should have multiple. So basically, these are 3 different tests in a row. If the first one fails, I don't know if the second and the third thing are still true, or whether those still work. So if you can, split that up into separate tests so that each tests only one thing. Think about the readability of your tests. Tests are also sometimes used as documentation of what the system should do. So describe what the intended behavior is and not what the current implementation is. This will help you understand what the current behavior is both now and in the future. So when this test fails in the future, you know, oh, I was making these changes and something actually broke, or I was making these changes and didn't think about how it would impact this other existing feature, and actually I need to change something here in line with the changes that we're making. And if you make your tests readable and give them names that express the intended behavior, that's going to help you in the future when you're working on something completely different and break one of these tests that you've written just now. The next thing is take into account the costs of these tests, not just of running the tests, or writing the tests, creating them, but of running them and the time that it takes to run them, and maybe analyze the failures and debugging them, or analyzing flakiness, and the time that it takes you to maintain those tests, because you need to maintain your test code just like you do your production code. Writing them helps you think about what the feature should do. And if the build takes too long, that will take you from the flow that you're in your work. If you're working on a feature, you run your tests, it takes too long to run, you've lost your concentration, you might move on to go do something else, and then it takes a while to get back into the things. So make sure that your build is fast. If you test the implementation and not the behavior, then if you change the implementation, you'll have to change all of your tests. This is a reason why some people don't like unit tests, because they're sometimes too tied to the implementation. And again, debugging failures takes a long time. So you want the test to tell you what's wrong quickly, so that you don't have to spend a lot of time in the future when it fails figuring out what went wrong. One of my ex-coworkers, Bart Enkelaar, said this during one of his talks. Test code is at least as important as production code. So it means that you have to maintain it just as you do your production code. It doesn't necessarily mean that it needs to adhere to all the same principles that your production code does. For example, one of the things that we try to do in our code is to make it dry, meaning don't repeat yourself. So you want to extract stuff that is used in multiple places, so that if you need to change it, you don't need to change it in multiple places. But for test code, sometimes repeating yourself is okay if it makes the tests easier to read. Of course, everything depends on your context, but do maintain your tests. So overall, test your code. Since this is a test conference, I don't have to tell you this. And if you want to see the slides with all of the links or previous versions of this talk, you can go to my website. You can use either the QR code or the URL. And I will exit the presentation so that we can see if you have any questions. I don't know if Sebi is here, though. Yes.
Hi, Marit. It was an interesting session. I'm sorry I was here only. So let's take some questions now. So our audience have bombarded with questions. So one of the questions I have is here. How do you recommend maintaining strong focus on software security during rapid development cycle? What role does security testing play in this scenario?
So there are lots of. The short answer is it depends. I'm sorry, but the longer answer is there are lots of tools that can help you in security testing or in keeping your application secure. One is to make sure that you keep your dependencies up to date and that you don't lag with older versions that might have known vulnerabilities. There are tools that can help you with that. I actually have another talk that you can find on my website on different kinds of tools that you can use for that. There are tools that you can use to scan your code to see if your code contains patterns that are known vulnerabilities. So that is something that you can automate. And of course, hackers that want to break into your software are way more creative than all of these automation tools. So especially, depending, and this is where the it depends comes in, depending on what type of software you are writing, whether if you're a very popular target like a bank, or in our case a retail platform that people want to break into, you will need ethical hackers to do penetration testing and see if they can actually find any exploits and use them, and then plug those holes. So security testing is, of course, very important, but depending on how popular you are as a target and the question, what can go wrong, might depend how much you want to invest in the using penetration testers and things like that. I hope that answers the question.
So do you want me to take another question now?
Yes, sure.
Sure. So we have another question on how can performance testing be interwoven with the development to proactively address performance issues and prevent delays?
So for Java, the tools that I mentioned, like JMeter and Gatling, are the ones that run on the JVM. You can integrate them into your build so that you can check the performance of your application. Of course, that doesn't say how your application will perform on the actual production hardware, etc. So there also, again, it goes to it depends. When I was working on the retail platform, we didn't do full-on performance tests at a production environment that I was aware of for our microservices. But when I worked at a bank before, we did do dedicated performance tests on the production hardware and making sure that everything performed as needed, because that was commercial banking. If it was slow, the impact would be way bigger than for a retail platform. I hope that answers it.
Amazing. It was really an interesting session, Marit. I really enjoyed how you walked through with memes and with the relatable content out there. It's really nice, and I really like the poem that you shared. So, as the session comes to an end, I hope everyone.
One more thing?
Yeah,
I,
please.
I think I think I mentioned it, but so the IDE I was using was 𝐴𝐴, which is our IDE, JetBrains IDE, specifically for test automation. And if you want to know more about that, please go visit our virtual booth. Thank you. Just wanted to get that in there.
Nice. So I hope that everybody must have enjoyed the session. It was really enlightening. And before we
Thank
move
you.
to our next session, I would actually like to tell everybody about the TestMu Social Bee challenge, where everybody can share their experience on Twitter and LinkedIn, and probably they can interesting prizes as well. So yeah, thank you everybody for joining us.